Today we're going to talk about solving radical equations. A radical equation contains a variable within a radical. Recall that you can solve quadratic equations by taking the square root of both sides. Similarly, radical equations can be solved by raising both sides to a power. Our steps for solving radical equations are first to isolate the radical. We want to have the radical all by itself on one side if possible, and then all the numbers and variables outside the radical on the other side. Second, we raise both sides of the equation to the power equal to the index of the radical. So if we have a cube root, we raise it to the third power. If we have a square root, we raise it to the second power. If we had a fourth root, we would raise it to the fourth power. The last step, step 3, is to simplify and solve the equation.
Our first example of a radical equation is going to be 5 plus the square root of x plus 1 is equal to 16. The first thing we need to do is to get the radical by itself. So we subtract 5 from both sides. This leaves us with the square root of x plus 1 is equal to 11. Now that the square root is by itself, we square both sides. Now on this side, the square undoes the radical, so we have x plus 1 left behind. We just take off the radical sign, and on the other side, we have 11 squared, which is 121. Now, we just subtract 1 from both sides, and we get a solution of x equal to 120. And that's our final answer. Our next example is 7 times the cube root of 5x minus 7 equals 84. So first we need to get the radical by itself. So we divide both sides by 7. 84 divided by 7 is 12, and that's equal to the cube root of 5x minus 7. Since the last one was a square root, we squared both sides. Since this is a cubed root, we are going to cube both sides of the equation, or raise it to the third power. So now we can take off the cube root on this side and get 5x minus 7, and that's equal to 12 cubed, which is 1728. Now to isolate the x, we add 7 to both sides, which gives us 1735 on this side. And last step, we divide both sides by 5, which gets the x by itself and gives us a solution of x equal to 347. Here we have 4 plus the square root of x minus 1 equals 5. Again, we want to isolate the radical first, so we subtract 4 from both sides. This gives us the square root of x minus 1 is equal to 1. Now, because we have a square root, we square both sides. We take off the radical. X minus 1 is equal to 1 squared, which is 1. We add 1 to both sides, so x is equal to 2. For this example, we have the cube root of 3x minus 4 equal to 12. The radical is already by itself, so our first step is to cube both sides because we have a cubic root. So now we take off the radical, giving us 3x minus 4 equals 2 cubed, and 2 cubed is 8. Next we add 4 to both sides. To get the x by itself, we have 3x is equal to 12. And then we divide both sides by 3. This gives us a final answer of x equal to 4. For this one, we have a square root on both sides of the equation. So we need to square both sides. So here we're going to square this side and this side. Over here we can just take off the radicals. So we get 7x plus 2 equal to On this side, however, we have a 3 outside of the radical. Anything outside of the radical needs to be squared. So this is going to be 9 times 3x minus 2. We can take the square root off of the 3x minus 2 here. Now we have an equation where we can distribute and then solve. So 7x plus 2 is equal to 27x minus 18. To get x by itself, we can put x on the left by subtracting 27x from both sides. This gives us negative 20x equal to, plus 2 equals negative 18. Make sure you don't lose your minus sign. Now we can subtract 2 from both sides to get the x's isolated. 20x equals negative 20. Now we can divide both sides by negative 20 to get a final answer. Anything divided by itself is 1, so x is equal to 1. So when you have a radical on both sides, you're going to square both sides of the equation. Just make sure that when you have something in front, a coefficient, that you square that as well.
If you remember back to when we did rational equations, sometimes we got an extraneous solution, or an extra solution. It appeared to be a solution when we solved, but when we plugged it in, we received an undefined answer, meaning that the 0 was in the bottom of the rational expression. We also have extraneous solutions in radical equations. Make sure that you plug in your solutions to make sure that they do not produce a negative radicand or a negative answer. That means that there is not a negative inside the radical, and you don't receive a negative as an answer.
Sometimes when we're working with square roots, we get something called an extraneous solution, which we also talked about in the previous PowerPoints with rational expressions. Now here, what we're going to do is take this square both sides, because we already have the radical by itself. However, notice we don't just have a number over here to square. We have an expression. So when we take this square root sign off of this side, we get minus 3x plus 33 equal to 5 minus x squared. Now we have to FOIL this side of the equation. So we write it twice because that's what it means for it to be squared. And now we do distributing. 5 times 5 is 25. 5 times negative x is minus 5x. Minus x times 5 is minus 5x. And minus x times minus x is a positive x squared. And we keep this side the same. Now we have to combine some terms. So we get minus 3x plus 33 is equal to x squared minus 10x, and that comes from minus 5x is minus 10x plus 25. Now we need to get everything on the same side, so I'm going to add 3x to both sides. Notice I'm adding it to the 10x because they're like terms. So this cancels out on this side and gives us 33 equal to x squared minus 7x plus 25. Now I need to subtract 33 from both sides, and that leaves me with 0 equal to x squared minus 7x minus 8. Now this is something that I can factor. So I'm going to come up to the top up here and do my factoring. 0 is equal to, this is going to be x and x because there's no coefficient, and we want to multiply to negative 8 and add to negative 7. So we get a minus 8 plus 1. To solve, I need to set them both equal to 0. X minus 8 equals 0, and x plus 1 equals 0. x is equal to 8 on this side by adding 8 to both sides, and x is equal to minus 1 on this side by subtracting 1 from both sides. So I have two possible answers. Either x is 8 or x is negative 1. So we have to go back to the original equation and try both. The square root of minus 3 times 8 plus 33 is equal to 5 minus 8. Okay, so we go ahead and plug this in. Square root of negative 24 plus 33 is equal to negative 3. Well, we already know that a radical cannot be a negative number. A square root cannot equal a negative number. A square root can only equal a positive or 0. So 8 is an extraneous solution. We need to cross it out. Now we can try negative 1. For negative 1, we get negative 3 times negative 1 plus 33 equals 5 minus 1. Now we get 3 plus 33 equals 4. This is negative 1. Sorry, this is negative 1. 5 minus negative 1, because negative 1 was our x. So this is going to be 5 plus 1. So the square root of 36 is equal to 6. And the square root of 36 is in fact 6. So 6 is equal to 6. And that solution works. So our final answer is that x does equal negative 1, but cannot equal 8. For this example, we have the square root of 2x plus 14 equals x plus 3. The radical is already by itself, so we need to square both sides. This gives us 2x plus 14 equals x plus 3 squared. Now we need to FOIL this side. So we have 2x plus 14 equals x plus 3 times x plus 3 if we distribute this, we get x squared plus 3x plus 3x plus 9. Combining our like terms, we get 2x plus 14 equals x squared plus 6x plus 9. Now we can subtract the 2x from both sides, and this gives us 14 equal to x squared plus 4x plus 9. And then we can subtract 14 from both sides to give us 0 equals x squared plus 4x minus 5. Now we're going to come up to the top up here and factor. So we need to get them to multiply to negative 5 and add to 4. So this is going to give us x plus 5 and x minus 1. Now we need to set both parentheses equal to 0 to find our x's. So here x is negative 5 and here x is 1. Now we need to go back and plug in to see which one is our extraneous solution and which one is our correct solution. So we start with x equals negative 5. 2 times negative 5 plus 14, and remember we're plugging it into this equation up here, is equal to negative 5 plus 3. It's negative 10 plus 14 equals negative 2. Now again, we know that a square root cannot have a negative answer, so we know that this is not going to give us a valid answer. So now we can try the next one. 2 times 1 plus 14 equals 1 plus 3. So we have the square root of 2 plus 14 is equal to 4. The square root of 16 is equal to 4. The square root of 16 is 4, so 4 is equal to 4, and that checks out. We have a correct solution, so x is equal to 1, and x is not equal to -5. For this problem, the radical is already isolated, so we're going to square both sides of the equation. On this side, we can take the radical off to get minus 9x plus 28. And on this side, we're going to have to FOIL. So we write this out as 2 parentheses. Now we can distribute. This side stays the same. And over here, we get positive x squared, negative times negative is a positive, minus 4x, minus 4x, plus 16. We're going to combine like terms to get minus 9x plus 28 equals x squared minus 8x plus 16. Now we're going to move the 9x to the other side. Since it's a negative 9x, we need to add 9 to both sides, and we add it to the minus 8x because that's where you have the like terms. So we get 28 equals x squared plus 1x, or x, plus 16. Subtract 28 from both sides to get the equation equal to 0. So we have 0 equals x squared plus x minus 12. Now we need to factor. So we get 0 equals, we need to multiply to negative 12 and add to 1, so we get x plus 4, x minus 3. Moving up to the top, we need to set both of those equal to 0. So x plus 4 is equal to 0, and x minus 3 is equal to 0. We solve the first one by subtracting 4 from both sides, which gives us x equals negative 4, and the second one by adding 3 to both sides, which gives us x equal to 3. Now we need to plug in both of the solutions to figure out which one is the extraneous solution, or the extra solution. Our original equation was square root of minus 9x plus 28 equals minus x plus 4. So we plug in negative 4, minus 9 times negative 4 plus 28 equals negative 4 plus 4. On this side we get minus positive 36 plus 28 equal to 8. 36 plus 28 gives us the square root of 64 equal to 8. So the first one checks out. So this is one of the solutions. Now we have to check the other one. Negative 9 times 3 plus 28 equals negative 3 plus 4. Here we get negative 27 plus 28 equal to positive 1, which is the square root of 1 equal to 1, and this one works out also. Therefore, both solutions are solutions to the equation. We have two solutions, x equal to negative 4 and x equal to 3.